Hello everybody, welcome to your 3-3 lesson on rotations. Our learning targets for today's lesson, we are going to be able to draw and describe the rotation of a figure about a point of rotation for a given angle of rotation. We will rotate a figure and write a rule for a rotation, and we will demonstrate that a rotation can be written as a composition of two reflections. You know what? Actually, we're not doing that last one. So if it feels good to cross off part of your learning target, go for it. Okay, so a rotation, here's what our notation looks like. It has a lowercase r. Remember, a capital R would indicate a reflection. So a rotation has a lowercase r. And then our little pointy parentheses, we have a degree measure first, followed by a point. It's a transformation. So a rotation is a transformation that rotates each point in the preimage about a point P, called the center of rotation. By an angle measure of x degrees, called the angle of rotation. So what our notation tells us is our angle of rotation about some point P, which is the center of rotation. So rotations have a couple properties. Well, first, actually, let's look at what it looks like. Here is point P. Here's our pre-image triangle ABC. So we're focusing on point A. If I take point A, and I can kind of have this imaginary line connecting the two, the center of rotation is point P, and then the degree, the angle of rotation in a counterclockwise motion. So counterclockwise is going like this, the opposite direction that a clock goes. So from here to here, that's our degree measure, and then that's where our image point will go, so our A prime. So our first property of rotations is the image of P, point P, is P prime. That means that P is equal to P prime. They're in the same spot. If you notice, P was our center of rotation. When we rotated, the center of rotation does not move. So P prime in our image over here is just the same point as P. The other property is for a pre-image point A, so let's find, here's our pre-image. So we're talking about this point right here. PA will be equal to PA prime. So the distance between P and A, after the rotation, we get A prime has the same distance to P. So all it's doing is it's rotating around. It's not getting further away. It's not getting closer to our center of rotation. A translation is a rigid motion, comma. So what does it mean when you have a rigid motion? Length and angle measure are preserved. All right, and then we're just going to make a note here, and I mentioned up there, a rotation is counterclockwise. For a positive angle measure. So what that's saying is, if you're rotating something 100 degrees, that means it's 100 degrees in the counterclockwise direction like this.